Welcome everyone. Today we're going to talk about stoichiometry and the arithmetic of equations. Your objective for today is to compare and contrast stoichiometry to a recipe in the cookbook. So we're going to use a cookbook as an analogy. And then we're going to describe the importance of a balanced chemical reaction. You should already know how to balance chemical reactions. So that is one of the expectations coming into this video and the next chapter, which is chapter 12. So what does a recipe tell us? If we were to have a recipe from a cookbook, let's say it was chocolate chip cookies, there are many parts to the recipe that tells us important information. For example, everything right here tells us the ingredients that we need. And it also tells us the quantities of each ingredient, whether it's 3 eggs or 2 cups of brown sugar that are packed, or 0.5 cups of unsalted butter, things like that. A recipe tells us the directions to make something, make a product. For this case, it's chocolate chip cupcakes, or chocolate cupcakes. And so it's very beneficial to have a recipe when you want to make chocolate cupcakes. Same idea with chemistry. The recipe can be used as a model for chemistry, in which case our reactants are our ingredients, your products are the thing you're trying to make, your end product, which is a chocolate chip cupcake, and the quantity or the coefficients are the amounts for each ingredient that we have to make a product, in this case chocolate chip or chocolate cupcakes. So why do we care? Why do we want to use this as a model? Why do we care about this? How does this help us? Chemists use balanced chemical equations as basis to calculate how much reactant is needed or how much product is formed. Just like we would if we wanted to increase our amount of food needed from a recipe or decrease how much we want to make from a recipe, chemists use balanced chemical reactions to calculate how much product is needed to make, how much product will be made if you have a certain amount of reactant. So if you're going to make a grilled cheese sandwich, you would need 2 pieces of bread and maybe 1 slice of cheese to make 1 grilled cheese sandwich. If you wanted to make 3 grilled cheese sandwiches, you would need to take these and multiply it by 3. So you get 6 pieces of bread that would be needed and 3 slices of cheese. Chemists use the same thing. What we just did here by multiplying it by 3 is stoichiometry. So we have a fancy word attached to it, and we just did stoichiometry to figure out how much would be needed in terms of grilled cheese. For chemistry, if we have nitrogen plus hydrogen making ammonia, so N2 plus 3 H2 molecules gives us 2 ammonia molecules, we know that if 1 mole and 3 moles make 2 moles. And so for every 1 mole of N2, we get 2 moles of NH3. And for every 3 moles of H2, we get 2 moles of NH3. So if we were to have 4 moles of N2 and 12 moles of H2, then we can make 2 times 4, 8 moles of NH3. So these equations give us ratios ratios of reactants to products that we can use to figure out how much is needed to make a certain amount of product, or how much reactant is needed if we wanted to make a certain amount of product. So in conclusion, we talked about how the stoichiometry is similar or can be modeled off of a recipe in a cookbook. And we talked about the importance of balanced chemical reactions and how ratios from the chemical reaction that's balanced is used to determine how much product can be made. This is just a simple introduction. We haven't added any math yet to it. The next video will talk about simple stoichiometry problems that we are going to be doing in class. Have a wonderful night. Before you come into class tomorrow, make sure you get down some notes. And try these problems. Maybe they'll be in a quiz or something tomorrow. You will need the following equation, which is the same one we did before. So it has the ratios already there for you. Other than that, have a great night.